Welcome to Comfort Learn classes. In this series of videos, I will explain the concepts of continuity and differentiability, and will solve some of the important questions from NCERT exercise, and will take few from model question papers and then previous year question papers. Apart from these questions, if you are stuck with any specific questions either from reference or from previous year, you can just put it in the comment section so that I can make a one more video for that. Let's see what is the continuity of a function. I will explain the concepts of continuity using some special types of functions. Let me take an identity function, right? So f of x is equal to x is an identity function. So is this function a continuous function? Or if it is continuous for what all the values of x. So now here, let me start with the graphical representation. So this is the graphical representation of f of x is equal to x, right? So this is our function. So now here we know that identity function is defined for all the real numbers, that is from minus infinity to infinity. And here you can see the line, okay, the graphical representation is continuous if you extend it here, or on this side it will be a continuous straight line, right? So now we don't have any discontinuous points here, right? So such functions are called continuous functions. If you want, let me take one more. If I take f of x is equal to mod x, right? So now this is our mod function. What is the graphical representation of mod function? The graphical representation will be somewhat, okay, similar to this, right? So now it is a straight line here. So now again, mod function is a real valued function. It is defined from minus infinity to infinity, right? So it is defined for all the real numbers. So now here again you can see the curve or the straight line is continuous throughout the input values, right? So even such a function is called continuous function. If you can draw the graphical representation, if you can draw the graph of the given function without lifting your hand, right, or without any discontinuity, then we call such functions as a continuous function. Even you can take f of x is equal to x square, right? So it is a quadratic expression. And for quadratic expression, what we get a parabola, somewhat similar to this, right? Okay, now here again it is a real valued function defined from minus infinity to infinity, and then here it is again continuous from minus infinity to infinity, a continuous curve, right? So this is the basic concepts of continuity of a function, right? If it is continuous, or the graphical representation is a straight line or a continuous curve without any discontinuity, we call it as a continuous function. Then when we call a function is discontinuous, or what kind of functions are discontinuous functions? So let me explain it with a greatest integer function, right? So we all know what is greatest integer function. If I take f of x is equal to greatest integer function x, right? So now here, what is the graphical representation? The graphical representation of greatest integer function is, let me take 1, 2 and 3 here, minus 1, minus 2 and then minus 3, 1, 2 and then 3, minus 1, minus 2, minus 3, fine. So now here, we know the graphical representation is 0, excluding 1, including 1, excluding 2, right? Because here if I take f of 0, what is the value? That is greatest integer function of 0 is 0, okay, f of 0 is 0. And if I take f of 0.5, right, so what we get here, f of 0.5 or greatest integer function 0.5, it will be 0 here, right? What is greatest integer function? Greatest integer less than the given value. 0.5 is given, what is the greatest integer less than 0.5? It is 0. So now if I take f of 0.9, so again still it is 0, greatest integer less than the given value. If I take f of 1, then it is 1. If I take f of 1.1, now still it is 1, right? 1.1 less than the greatest integer less than the given value is 1. So now this is the graphical representation. So now let me check at x is equal to 1, right? At x is equal to 1 is the function continuous. You can see here, if you start drawing the graph here, So now there is a discontinuity. You need to lift your hand and then you need to start again from this point, right? So now obviously it is not continuous at x is equal to 1. So that we get from the graphical representation. All right, right? So now at x is equal to 1, the function is not continuous, right? So similarly, if you take 2 to 3, it will be somewhat okay. So now again it is not continuous at x is equal to 2. But if I ask you the continuity of the function, or is the function continuous for x less than 2 and then greater than 1, excluding 1 and 2, right? So now here if I take 1 to 2, now you can draw a continuous line here, right? So you can write f of x is equal to greatest integer function x is continuous for x less than 2 and then greater than 1, but it is discontinuous at integral points, okay? So what are integral points? That are x is equal to 1, x is equal to minus 1, x is equal to 2, 0, all these points the function is discontinuous. So this is how we explain the concepts of continuity using the graphical representations, right? Fine. If you take f of x is equal to sin x, what is the graphical representation? If I take the function sin x, the trigonometric function, so we know that the graphical representation is like this, correct? So now, is it a continuous function? Yes, it is a continuous function because sin is defined for all the real numbers minus infinity to minus infinity plus infinity. So if you draw a graph, you can draw it without lifting your hand, right? So hence it is a continuous function. And if f defined by f of x, that is x square sine of 1 by x if x is not equal to 0, and 0 if x is equal to 0. So here we need to check the continuity of the function. So before that, let me define the function here. So if x is either less than 0 or greater than 0, then the value of the function is x square sine of 1 by x. And if x is equal to 0, then the value of the function is 0. So this is how the function is defined. So now we need to check the continuity of this. So now here what I will do, I will divide this region into 3 parts, that is x less than 0 and x greater than 0 and at a point x is equal to 0, right? So now we need to define continuity in these 3 regions. So if you take x less than 0, we know the value of the function is x square sine of 1 by x, right? So by using the algebra of continuity, if x square is continuous and sine of 1 by x is continuous, then the product of these two is also continuous. X square is a polynomial, right? It is a polynomial expression and we know polynomial is a continuous function, right? So now here it is continuous, and similarly sine is a continuous function because what is the graphical representation of sine? So somewhat similar to this, right? It is a continuous curve, right? So sine is a continuous function. So this here is continuous. So product of these two is also continuous. So you can just write f of x is continuous for x less than 0. You can take the same here because for x greater than 0, the function f of x is x square sine of 1 by x, right? So now we are done with the first 2 regions. In these 2 regions, the function is continuous. So now let me check for the specific point. So when you want to check the continuity of a function at a specific point, so here you need to check limit x tends to 0, f of x is equal to f of x, right? If these two are same, then the function is continuous at a given point. So now using the concept of limit, right? So from the pu first here, we will find the limit first and then we can find the f of 0. So now here, if I take limit x tends to 0 and then the function is x square sine of 1 by x, right? So let's solve this one. right? So now here you can't make a substitution here. You can't make a direct substitution, because if I take a direct substitution, what I get here, I will get a sine of 1 by 0, which is not defined, right? 1 by 0 is not defined. So you can't take a direct substitution, or you can't make a direct substitution here. So now what I will do, I will use some of the rules or the formulas from limits, and then I will try to simplify this. So now the same expression can be written as, right? So what I will do here, I will keep this, I will write this x square as x dot x, right? X square can be written as x into x, and then we have sine of 1 by x, right? So now again, limit x tends to 0, I will keep this 1x here as it is, and I will keep this sine of 1 by x again as it is. Now what I will do, I will take this x here, and then I will bring that to denominator. So how can I bring it to denominator? I can write it as 1 by x, right? So if you simplify again, you will get the same x here, right? If you take it to the denominator, this x will become 1 by x. So this step is important, right? So now what we got here, I took this x in the denominator, then we got 1 by x. So next step, again by using the algebra of limits, limit x tends to, limit a b can be written as limit x tends to 0 a dot limit x tends to 0 b, right? So now I will write it as limit x tends to 0 x into limit x tends to 0 sine of 1 by x whole divided by 1 by x. Fine. So here you can make a substitution now, right? If I make a substitution, what I will get, x is equal to 0. So this is 0 here. So now here we know limit x tends to 0 sine of x divided by x is equal to 1, right? So we know this one from first year. So now I will make this as 1, then the product is 0, right? So this is our limit x tends to 0, f of x, we got 0. And what is f of 0? It is given in the question. What is given here? For x is equal to 0, the value of the function is 0, right? So limit x tends to 0, f of x is equal to f of x. Fine. Hence the function is continuous even at x is equal to 0, right? So there is no point of discontinuity. The function is continuous for all the real numbers, right? So now this part here is important. Just you need to remember this one, right? This x in the denominator 1 by x, then this will become to 1, and then product is 0. Fine.